Hi guys, so this is chapter 9, which is quantizations of light. So in previous chapter, we learned that light can behave as a wave. So in this chapter, we're going to look at that light can behave like a particles. So first of all, we have Planck quantum theory. So Planck quantum theory is basically stated that electromagnetic wave or EM wave can only be released in a discrete packets or quanta. Okay, so in other words, we can say that light can behave, so instead of kita nampak light sebagai satu benda, satu cahaya yang panjang, light ni kita boleh katakan sebagai a discrete packets. So dalam light ni basically there satu particles, yang this is what made up of the light. So kita ada cahaya, so dalam cahaya tu basically ada small particles. The combinations of the particles tu adalah yang made up of the light lah. Okay, the energy can be carried by one of these wave packets had to be E equal to HF. Okay, so E is the energy of the photon. Okay, so ni 1 lah. Kalau photon awak 1, there will be 1. So ni kita berkata sebagai energy of the photon. So satu-satu partikel ni nama dia kita namakan sebagai photon. So E is energy of a photon, one photon, equal to HF. H will be the Planck constant, which is down here lah. So Planck constant is 6.63 10 - 34 joule second. F will be the frequency of light. So this is for one photon. If there's many photons, NH over F. So ni N is number of photon. Right? So then we gotta know that to distinguish between Planck quantum theory and classical theory of energy. So basically Planck quantum theory is a modern theory lah. It's upgraded from the classical theory. So look at here, in Planck quantum theory it stated that energy is radiated in discrete packet of energy. Okay, so basically kat sini nak cakap dia ada photon lah. The existence of the photon. Okay, so classical theory kata energy is radiated in continuous form. Continuous form ni can be said as satu benda yang panjang. Macam kita nampak cahaya, kita tak nampak pun dia punya photon, which is a particle inside the cahaya, tapi kita nampak cahaya as a whole thing. That is what meant by continuous form. So second one is energy is dependent on the frequency. It means that the higher the frequency of your light source, so the higher will be the energy of the light lah. Okay, tapi classical theory kata energy is independent of the frequency. So kalau basically classical ni nak kata energy is depending on the intensity. Intensity tu adalah kecerahan suatu cahaya tu. Kalau kita guna lampu spotlight, means that it has high intensity lah. High intensity, high energy. That is what classical cakap. Regardless of the frequency of the light. Okay. So 9.1c ni kita ada belajar pasal Einstein equation for photon energy. So photon energy cahaya lah. So energy of the photon E equal to HF equal to Hc over lambda. So basically yang belakang ni adalah derivation daripada V equal to F lambda. Because this is a photon, so ni adalah C equal to F lambda, F equal to C over lambda. So just substitutekan macam tu lah. So C will be the speed of light. Speed of light is a constant. Okay, E awak ni mesti dalam joule lah. But sometimes the questions that give you energy in electron volt. Okay, electron volt ni one of the unit for energy lah. Okay, so to be able to use the equation, E must be in joule. So first of all, if you get energy unit is electron volt, you got to convert into joule, then only you can use equation. So for example, you dapat 1 electron volt. So 1 kali E is electron charge, 1 10 - 19. So you akan dapat 1.6 10 - 19 joule. So means that first of all, you got to make sure that unit for energy must be joule. Okay, kalau kita tengok kat sini, kita ada photon. Dan when photon strike a metal surface, dia keluar warna biru tu lah, which is a photoelectron. Okay, so basically apa yang kita tengok, what you watch just now from the video, is photoelectric effect. Photoelectric effect is defined by the emissions of electron from the surface of a metal when the electromagnetic radiation ataupun light of higher frequency strike its surface. means that there is a specific frequency that allowing the emissions of electron. Dia bukan semualah yang cahaya kena surface, electron terus keluar. Tak, dia depends on the frequency of the light as well. And also the type of the light lah. Okay, then kita ada photoelectric effect experiment. Okay, basically the main point of the experiment to prove that light has a particle properties. Okay, cahaya ni menjadi particle juga. Kalau kita tengok dekat sini, okay, kita ada diagram. So dekat diagram ni, this is basically is photoelectric effect experiment. So we have this is cathode because it's attached. Kita power supply dulu. Kita power supply negative, positive dan sebagainya. So negative ni this will be cathode negative, anode will be positive. So this one here, okay, so kita ada voltmeter. So voltmeter must be connected in parallel because it measures the potential difference. Okay, then kita ada ammeter. Ammeter must be in series because it's basically measuring the current flow in the circuit. Okay, so kita tengok this is negative. So it's a negative here is a cathode lah. Okay, kalau for here, cathode will be act as an ammeter. Then anode will be act as collector. So kalau kita buat dekat sini, so what we're going to do here is this experiment must be held inside the vacuum. So dekat sini, inside the vacuum first thing. Okay, so what we're going to do is we're going to radiate some electromagnetic radiation. Okay, which is we're going to put in some light here. Okay, light ni akan kena dekat cathode. Okay, kat cathode. What going to happen is the electron will be ejected from the cathode and reach the anode. Apabila ada elektron lompat daripada cathode ke anode, dia dah sampai kepada anode. So, circuit awak ni akan full dan akan ada bacaan dekat ammeter. Means that there's a current flow lah. So, previously, before we strike any light into the cathode, okay, circuit awak ni basically dia terputus sebab kat sini tak ada apa-apa connection. So, then bila we put in some light here, dan elektron lompat daripada cathode kepada anode, dia sampai kepada anode, circuit awak dah lengkap, ada bacaan dekat ammeter. Okay, kenapa ammeter ni kita letak sebagai cathode? So, our main point is here is to eject electron. So, bila kita this ammeter ni kita letak sebagai cathode, which is negative terminal. So, you tahu kan ni negative dan electron is negative charge. So, it will be repelling the electron. Kita akan repel kat elektron kita ni lah. So, yang dia collector ni anode, there will be positive charge. So, dia akan attract electron. Lagi senang lah. Elektron nak keluar senang sebab kena tolak. Dan dia bila nak sampai anode, dia akan ditarik. So, it will be easier for electron lah. And your circuit will be completed. Okay, so kalau explanation, light shines on the cathode. Electron ejected from the target metal and reach the collector, which is the anode. So, hence that is meant by the current is flow. Therefore, the photoelectric current is detected by the ammeter. So, as I said, setup must be done in vacuum so that the electron does not lose energy due to the collision of air molecule. So, dekat sini kan electron ni kita cakap sebagai photon, which is discrete packet. Okay. So, kalau kita ada dekat air, so kata kita H2O kan, dekat H+. Daripada nak pergi kepada anode, terlanggar pula dekat H+ ni. So, gonna lose energy. Mungkin tak cukup energy pun nak sampai kepada collector. Okay, untuk to get rid of those possibilities, so kita buat dalam eksperimen dalam vacuum. Okay, tengok kat sini, photon pergi collector dan cathode tu, lepas tu ada elektron keluar sampai dekat anode, circuit full. Photoelectric experiment. So, next kita boleh buat, untuk eksperimen ni kita boleh adjust untuk determine the stopping potential. Okay, stopping potential is a negative potential to stop the emissions of electron. So first step, apa yang kita akan buat, kita akan reverse the polarity of the power supply. Okay, kalau tengok yang atas ni, ammeter yang kat sini, ammeter ni are connected to negative. So now, ammeter ni dah jadi anode connected to positive. So kita akan pusingkan tu dahulu. So ni akan jadi positive, ni akan jadi negative. Okay, then kita ada rheostat. Rheostat is variable resistor lah. Okay, so what can do here, basically kita akan, power supply ni pun kita akan variable power supply. So what we can do is we adjust this power supply. Kata kita start dengan 0 volt. Dan kita naik 1 volt, 2 volt, 3 volt, 4 volt. Okay, kita adjust the value of power supply sampai tak ada bacaan dekat emitter. Tapi kita still ada current, light will be still hitting the emitter lah. Okay, so cahaya constant letak dekat emitter, tetapi kita adjust the power supply sampai tak ada bacaan dekat emitter. Bila tak ada bacaan dekat emitter, maksudnya tak ada current yang tak ada elektron yang sampai kepada cathode ataupun collector. Okay, so kalau kita kat sini, the first start, we got to reverse the polarity of power supply. So tadi emitter adalah cathode, sekarang emitter adalah anode. Collector adalah cathode. So we got to vary the potential till no current is detected at the emitter. So the voltage recorded is a stopping potential when there's no electron reach the collector plate. Okay, so macam sama juga macam tadi. Kenapa emitter kita letak sebagai positive plate? Sebab bila kita increase the power supply, so apa yang jadi dekat sini adalah kita akan make kan emitter plate ni sebagai more positive. Bila dia more positive, dia akan tarik elektron lagi kuat. Lagi tinggi dia punya voltage, lagi tinggi tarikan dia terhadap elektron sampai elektron pun tak boleh nak keluar daripada emitter punya plate. Therefore, dia tak sampai dekat sini. Sama juga dengan collector ni, negatif ni. So, dia akan mula sikit negatif. So, dia boleh ambil elektron. Bila dia punya negativity of the plate lagi tinggi, dia akan repel the electron tu. Kalau ada, dia akan repel supaya tak boleh masuk. Sebab negatif dengan negatif kan bertolakan. Next, kita ada several terminology dalam chapter ni. First, kita stopping potential. Tu yang saya buat explain tadi, yang kita reverse the polarity of the power supply. Okay, stopping potential is defined as minimum value of negative voltage when there is no photoelectron reaching the anode. Maksudnya circuit awak terputus lah. So, bila circuit awak terputus, there's no reading on the emitter. So, basically apa value of V yang kita dapat tu adalah stopping potential. So, stopping potential ni memang definition is negative value, negative voltage. Maksudnya tak perlu tulis negatif pun lah, just tulis V awak berapa. So, it's understood is negative. Then kita threshold frequency. Threshold frequency is defined as minimum frequency. Minimum frequency of the electromagnetic radiation required to emit an electron from the surface of the metal. So, kalau maksudnya, kalau metal awak tu kata, this is F0 lah, threshold frequency ni. Ni adalah Vs, this is F0. Okay. Kalau kata ada metal surface, frequency of the F0 ni adalah, katalah 1 Hz. Okay, maksudnya F0 will be the minimum frequency required. Kalau cahaya awak datang 0.5 Hz, elektron tak keluar sebab dia tak lepas daripada F0. Kalau F awak adalah 2 Hz, lepaslah elektron will be ejected from the surface of the metal. Okay, so kalau kita tadi saya tunjuk F equal to C over lambda. Kalau nak cari wavelength threshold, so jadikan F0 C over lambda naught. Your speed of light ni is remain constant. Then kita ada work function. Work function ni pula adalah minimum energy required to emit an electron from the surface of the metal. It depends on the metal used. So kalau tadi threshold frequency dan threshold wavelength, there will be minimum wavelength dan minimum frequency. Dan minimum energy kita tak panggil E0, kita panggil sebagai work function. So W0. Okay, it depends on the metal used. So, kalau kita guna different metal, the only thing is that we are able to change the work function if by changing the material used. So, kita boleh guna W0 equal to HF0. Kalau nak cek lambda, guna equation yang atas ni lah. Dekat sini. Experiment, there are two. So, before we do the experiment, there's some expectation on what are the things that we're going to observe from the experiment. So, the expectation for the experiment is based on the classical wave theory. Okay, so here we have classical wave theory. Then, kita ada experimental observation. Kalau classical wave theory ni, first of all, we're going to talk about time. So, electron, dia kata, electron must get sufficient energy before emission. Hence, there is a time lapse between irradiation and emission. Okay, delay increases if the intensity is low. So, based on here, it said that there's a time needed for the energy transferred from the light to the electron. Dan bila macam light tu datang, cahaya tu kena transfer energy from cahaya ke elektron. Dan elektron dapat energy, baru elektron boleh jump from the metal surface. means ada time lapse lah between them. But then when we observe from the experiment, emissions of electron happen spontaneously. Okay, so first of all, we talk about time. Okay, second one, the higher the intensity, the greater of the energy imparted to the metal surface for emissions of photoelectron. So kalau kat sini nak kata the energy of the photon is directly proportional with the intensity. Okay, so kalau kita guna lampu yang cerah, which is such a spotlight. Okay, spotlight cahaya yang cerah. So intensity tertinggi, so means the energy of the photon will be greater lah. So maksud yang dia kata kat sini. So bila kita buat eksperimen, dia kata maximum kinetic energy of the photoelectrons does not depend on the intensity of the light. Okay, very low intensity but higher frequency. So bila kita guna, walaupun dia malap, tapi because the frequency of the photon is greater than threshold frequency, there are still some ejections of photoelectrons. Okay, so maksudnya dia tak depend dengan intensity lah, dia depend dengan frequency. Third one, dia kata emissions of photoelectron occurs for all frequencies of radiation. Okay, so basically regardless of the frequency of the photon, kalau dia cerah, dia akan eject electron. Energy electromagnetic radiation is independent of the frequency. But then when we do experiment, kita ada existence, we figure out the existence of threshold frequency. Emissions of photoelectrons occurs only when F is greater than F0, which is frequency of incident light axis threshold frequency. So 3 benda lah. So first kita ada time, then kita ada intensity, then we have frequency. So soalan ni kalau keluar, kita kena cakap 3 benda lah, differences between classical wave theory dan experimental observation. Or this one kita boleh cakap sebagai modern theory. For this chapter, kita akan guna Einstein photoelectric equation. So equation ni is to represent the photoelectric experiment jugalah. So first, dari K max, K is the maximum kinetic energy of electron. Okay, then equal to EVS. E will be electron charge lah. So kita akan ambil dia punya magnitude sahaja. Dan kita ada VS. VS is a stopping potential. So kalau soalan kata dia macam VS kan. So definition VS is negative stopping potential lah. Okay, so tak payah letak negative. So VS is dependent on the frequency of the photon. Then kita ada HF, the whole thing here is the energy of the photon. So minus W0. W0 is a work function lah. So to change the work function, the only things that we can do is to change the type of the metal used. Okay, so kalau kita kat sini, K max ni is the maximum kinetic energy of the electron. So M ni will be the mass of the electron. Okay, so again, kalau kita nak guna equation ni, make sure that everything must be in SI unit. So means that the unit for energy must be in joule. Tak boleh guna dalam electron volt. Okay, for this chapter kita ada 3 graphs. So this is graph of photoelectric experiment. The first one will be kinetic energy against frequency. So first of all, when you get the questions, you're going to see the axis of the graph. So kita ada K max versus frequency. So it's a linear graph basically. So the intersection between the x-axis there will be F0. Then kalau kena buat axis will be negative W0 lah. So K max increase linearly with the frequency. K max will be the kinetic energy of apa? Of the electron. Okay, when K max is equal to 0, F equal to F0. So x-intercept of the graph is the threshold frequency. When F is 0, K max equal to negative W0. So y-intercept is the work function. So if you look at the axis, then you can determine lah F0 x-intercept tu adalah F0, y-intercept adalah W0. Okay, tadi K max versus frequency sama juga yang ini. Okay, kalau kita ada dua material, so because W0 is depending on the material. Nak tukar W0, kena tukar jenis material lah, metal yang kita guna. So work function depends on the material. W equal to HF0. Okay, so W0 lah. W is directly proportional with F0. So as the F0 is greater, okay, kalau dia guna metal with higher work function, greater work function, dia punya F0 will be greater. Since Kmax is equal to EVS, stopping potential Vs increase with the increasing of frequency. So Vs dengan Kmax ni bergantung dengan frequency of the photon used. Okay, so saya tulis kat sini. Kmax and Vs depend on frequency of photon. So Vs and Kmax are independent of intensity. Tak kisahlah lampu awak cerah macam mana pun, dia tak akan memberi efek kepada Kmax dan juga Vs. Okay. So next is photoelectric current versus voltage. Okay, so from the experiment, the photoelectric current is directly proportional to the intensity of the radiation. So current ni is directly proportional with the intensity. Okay. Light of a greater frequency but constant intensity but constant frequency. Frequency kita sama, intensity kita naikkan, delivers more photons per unit time. Maksudnya bila intensity awak tinggi, lagi banyak photon yang akan sampai kepada metal surface. So menyebabkan the number of electrons ejected per second increases as the intensity of the light increases. From the graph, stopping potential is the same for both intensity. Stopping potential ni kalau kita nak ubah, kita kena ubah dia punya material yang kita guna, ataupun kita boleh ubah frequency of the photon. Okay. So the only effect of increasing intensity is to increase number of electrons per second, hence the photoelectric current. So kalau kita ingat balik, current is I equal to Q over T. So kalau lagi banyak elektron yang bergerak per unit time, I awak will increase. Okay, so kalau kita tengok dekat sini, kita ada intensity first, double intensity. So basically with constant frequency. Okay, sebab tu Vs is sama, sebab frequency of the photon is the same. So bila kita naikkan intensity increase. Okay, so apa yang kita akan buat? More photons, now of photons per unit time increases. So electrons per unit time pun akan increase. Lagi banyak elektron yang akan keluar. Bila lagi banyak elektron yang akan bergerak pada suatu masa, current will increase. Sebab tu dekat sini bila intensity naik, current awak pun akan naik. So begitulah kesnya. Okay. So itu sahaja for chapter 9. Basically we are done with chapter 9. So now we'll look at the questions for chapter 9 pula.